Hi students, in continuation to this statics problems which we solve, today let us we look into this one more problem which is very important. This is one of the problem which give the idea about using equilibrium equation to solve unknown forces and moment. This is a force and a couple combined problem. You can understand all the concept of 2D, 3D equilibrium equations and extracting the estimating the value of forces in x, y, z direction. As I said that any vector quantity like a force is associated with the direction. The sense of direction, as the direction can be found, you can determine the direction of that force using the unit vectors, determining the unit vector and the direction, and multiplying with your magnitude of the force, or you can use the angles at which the force acts resolving the x, y, z axis, or you can use the slope of at which the force acts. So the unit vector can be extracted, or you can estimate the unit vector either using a position vector or the force vectors or any other vectorial quantity of that directions. So if you see here, this is the force and couple of force star problems. You see that brackets which is in a three-dimensional attached to a wall. There are cables which is also attached. So now replace the what we are going to solve is replace the force exerted by the cable with an equivalent force of force coupled system at A. So what is the equilibrium condition if you take these forces which is acting on different direction, and what kind of equilibrium condition at A could satisfy the equilibrium equation. Both the force, sum of the forces and the moment has to be 0 to maintain the equilibrium conditions. So we look into that. There are x, y, z direction, and there are positions which are mentioned. There are angles mentioned. The force which is acted D, B to E, and there is C. At C there is 1000 Newton which is act. At B 700 Newton acts. At D 1200 Newton acts. So there are positions vectors. Positions are given. So from that we can estimate what is the unit vector and project that unit vector into the force scale magnitude, and then finally we will get all the xy direction. From that we can set a equilibrium condition. What is the equilibrium condition? Sum of the forces in x direction and y direction and z direction independently 0, or some of the forces. Similarly, the moment at A should also be 0. This is how we are going to determine if we set the condition of the equilibrium. So let us see that. First, what we have to do, draw a free body, remove the constraint, and we have to. If you draw the free body, if you see that, first we know that what is the FB. If you look into the FB, it's a 700 Newton which is act. So you have to multiply with the unit vector BE. If you want to find out the unit vector BE, so first the vector, what is the vector BE, and the magnitude of the BE. So that if you found extracting from the using the x2 minus x1, y2 minus y1, z2 minus z1 of ijk of that direction. I is the x direction, j is the direction, k is the z direction out of the plane. Okay. So if you look into that clearly, you will get that lambda b. So 75i minus 150j plus 50k. So divided by that magnitude of that is 175. So similarly, now if you find the vector AB, AC, AD, we will get these parameters, and the unit vector for that each direction we can similarly find out the magnitude, corresponding magnitude. The vector divided by the magnitude will give the your unit vector in the direction. So FB is equal to 700 lambda B. So multiply with that, you will get FB. FC. FC is you resolve X in the Z direction, and Y direction is not there, the force set. Similarly, FD is X and Y direction, Z direction is not there. So the sum of the forces, if you make it, so adding these forces to maintain this equilibrium condition, the resultant forces has to be to be add all the X forces, Y forces, Z forces. But you get the resultant force is 1607 Newton, and the 439 Newton, 507 Newton. The resultant force, it has to be there so that to maintain the equilibrium. 1607 Newton and 439 Newton and 507 Newton. That is in the Z direction, which is opposite of the positive against. So that's how we get a resultant force. So now, if you move to that, to finding out the moment of that each forces acting at A, so you have to multiply with the force, the position vector, and the cross product of the position vector and the force, corresponding forces. So to do that, it's a very simple method is because it's a vector quantity. So ijk is the vector, unit vector in the directions. Respective direction x, y is z. Similarly, the value of r and the value of force. If you do that cross product and find out, it is finally r of that BA or AB vector in the FB is equal to 30I minus 45K. Similarly, CA vector in the FC is equal to 17.68J. And similarly, if you add AD and cross FT is equal to 163.9K. So the moment has to balance for the equilibrium, the moment at A should be 300 Newton that meter is ith directions. So and 17.68 Newton meter is in the jth direction. This is a torque. So and 118.9 Newton in the meter, that kth direction. So this is the kind of moment and force required to maintain the equilibrium conditions. So if you wanted to represent, you see that anything which is act in xy direction, the resultant rotation would be in the k direction. So why it is a minus sign means that is in the clockwise direction. So anti-clockwise directions are a positive quantity. So if you add this thing, and then what we are getting is finally is a kind of torque at A, and the force corresponding the force also is given xy z direction. What is the force that is resolved into? So this is the way you have to approach any problem of the statics, whether it is a 2-dimension or 3-dimension. You must understand that you have to basically find out the component of the forces, or find out the resultant forces, adding this component of the forces, find out the resultant forces, and find out the unit vectors and projecting that to the magnitude of the force. That would give you a vectorial representation of the force in the x, y, z direction. I hope you understand this. And if you practice, if you understand this problem, you can solve any problem in the statics, whether it is a 2-dimension or 3-dimension. This is a very key problem which you have to practice and understand. Thank you. I hope you do well in your examination. Hi student, I hope you are doing preparing for the examination very well. My best wishes. You just look into this some few problems that may help you do well in the examinations. This is especially about the industrial expert talks and the problems in a rigid body in a plane, the motion of rigid body in plane. If you look into that, a rigid body is a non-deforming. This is just like that, what you are seeing. If you apply many forces common around that, for example, there are many directions you can apply a force in a plane. You think about a plane. So if that is the rigid body, it has the geometrical center, that's the mass and the center of mass. If the various forces act on it, what would have happened? This body will be translated as well as rotated. Depends on the how these forces can be resolved whether it is it's both in a translation as well as in the rotational motion. This is what you see that in the rigid body, the G is the center of mass center, and F1, F4, F3 is acting in a plane in the rigid body. You can resolve these forces into a torque about the center of mass and the translation motion in the of the center of mass. That is M into A. A is the acceleration of the center of mass, and H is the rate of change of angular momentum about G. So that is nothing but a torque. So the angular momentum of the rigid body about the mass centers. If you rate of change of that will be a torque. This specifically this kind of forces you can resolve in the x direction and y direction, and the moment you can write as a moment of inertia and this angular acceleration. Some of the forces in FFX related to mass and acceleration in the x direction of the center of mass, and the y direction, similarly in the y direction, mass and acceleration in the y direction. So that's what we call it as a D'Alembert's principle. So any rigid body motion in a plane plane motion of the rigid body, so you can resolve into translation as a force in the x and y direction, and the moment you can resolve into I into alpha, that would be in the out of the plane, the direction. So let us look into the simple problem. This is the equation of motion of for a rigid body. When the forward speed of a truck as shown was 30 feet per second, so the truck moves at 30 feet per second. When the brakes are suddenly applied, causing all the four wheels to stop rotating. So you are applying a brake, the wheels are. So what would have happened? Truck probably a skid. It's getting, because of that sudden brake. So when it stops, there is still a momentum which that would cause a skidding, rate of change of momentum. Okay. So the truck is skidded to rest at 20 feet. After the brake applied, it just is skidding to the 20 feet. So the question here is determine the magnitude of the normal reaction and the friction force at each wheel as the truck skidded to rest. So here the friction is involved, the kinetic friction is involved, and there is a normal force. So what you have to do is there are four wheels, because it's a plane in a plane motion of the rigid body in a plane. So you can consider a two-wheel system, and finally you can divide that force because it's a symmetrical nature, where G is the center of mass, center of gravity, whatever. So here because the gravity acts. So now what you have to resolve these into forces and moment about A. If you take that equation, equilibrium equation, you can easily find out. Before that, you're supposed to apply equation of motion to find out what is the acceleration in the x-axis. So because as soon as you apply a brake, there is a deceleration, so it has to travel 20 feet to come to a rest. So that you take into account using the u square initial speed and the v square, the 2ax. That is the kind of equation of motion you're supposed to use to find out what is the ax. So v naught, we know that 30 feet per second, and v square is equal to u naught square plus 2ax. You know that it's come to rest, so that the final velocity is 0. So you substitute that, you find out what is the a. A is the deceleration, it is a minus 22.5 feet per second square. So now you know that there is the acceleration, deceleration which is acting, there is a velocity, and what is the normal reaction, which is just a weight of the act at the center of gravity at G. So you can easily find out what is the it is a mass into G, acceleration due to gravity, that is given. So you can now you think about, you resolve in a y direction, x direction, and if you look into that, the normal reaction at A, normal reaction at B minus W is that, because if you look into this directional, the right hand direction, which we are doing all the problem, so counterclockwise moment is positive, clockwise moment is negative, force upward is positive, downward is negative, right hand side is positive, left hand side is negative, out of the board is positive, into the plane is negative, so something like that. So you have to take the sense of direction. Here it is mentioned. So friction force FA plus FB, because which is act against the the motion, so you take a negative signs. Similarly, this is a deceleration, m into a. So you finally you will get FA plus FB is equal to mu k into NA plus NB. This is comes from your friction, kinetic friction constraint equations. So that's equal to mu k into W, weight of the vehicle. So from that you can find out, you know that acceleration due to gravity in feet per second square is 32.2. So substitute that, you will get a mu k is equal to 0.699. So now there is some parameters which is still we need to undertake, which is we can't still there are some unknowns we need to estimate, especially NB. What is the NB in terms of W? So now if you take the moment at A, so you will get know that what is the NB in terms of W. So FB is equal to mu k into NB. So finally you will get FB is equal to 0.454 W. That is the weight of the vehicle, of that friction force which is acting in point B. Similarly, if you Fy, if you take that NA, you will get it, and Fa is equal to mu k into Na. So the finally it is a 0.245. So in each wheel, if you look into that, in each wheel you have to divide it by 2. So you will get what is the front wheel and the rear wheel, what is that in terms of W, because W which is the weight of the vehicle, which is not given, but you can still assume that it is a known parameter of W. So this is how you have to. So let me again emphasize that as soon as you have the problem, you have to draw a free body diagram and resolve these forces in the x and y direction, and take the moment if there is an unknown component. From that we can converge very quickly to that what is this needed and that. So now we see the second case, the second problem. Car shown in this figure has a mass of 2000 kilogram or 2 capital mg. The center of mass at G determine the acceleration if the rear driving wheels are always slipping, whereas the front wheels are free to rotate. The condition, the constraint here is if the front wheels are free to rotate, means there is no friction. The rear wheels are slipping, means there is a friction. Neglect the mass of the wheels. The coefficient of kinetic friction between the wheels and the road is given here. So you know that. So now what you have to do immediately, take this dimension and apply the load condition, and draw the free body diagram and fix your coordinate system as it's given. So these are the 2000 into 9.82 Newton. These are the parameter. So now you resolve that FB, FA is not there, as you said that there is a free to rotate, means there is the front wheel is a zero friction. So FA is equal to 0, but there is a still, it's a NA, the reaction force NA, NB, AG, there are three unknowns are there. So you have to take the moment at either G or any one of these point A or B to solve this. So let us again we just to put into the practice that what is the f of x, mass in the acceleration, that was what is the f of y, mass in the acceleration in the y direction. So if you substitute that 0.25 NB is equal to, that is the in x direction the friction force is equal to 2000 into AG. Similarly Fy is equal to, we substitute NA plus NB minus 2000. So you know that NA and NB in terms of 2000 into AG. So if you solve that, you will find out the moment at G. You can take a moment at A or a moment G, so it depends on moment at B also you can take. So whether it is quickly converged. So the moment at G is given by NA, and the normal action is 1.25 m and minus 0.25 NB into 0.3 m plus NB into 0.2. So the sign convention basically it's a clockwise negative, anti-clockwise positive. So based on that you have to put, finally you arrive at the AG. What is the AG? Is 1.5 meter per second square, that is the acceleration in the x direction. But here it is a kind of deceleration, or if it is a positive, this quantity is positive, so the vehicle is in this direction, so you can take that. So NA is equal to 6.88 kN, NB is equal to 1, it's kilonewton, basically kN is a kilonewton. So this is how, as I said that you can take it at MA also to find out that, so you will converge the same result as I said that. So so you have to be little care about the direction, sense of direction when you take. So these are the quantity NA, NB and acceleration at G. That's what you are. So you can solve in a, but you have to consider that resolve that forces in the x and y direction of the center of mass and rotation about the center of mass or center of gravity. So that's how it is converged, and either you can take it as a or and B or a G, depends on how. But this equation is going to be, if you are taking it a G, that some of the rotation is not about G is 0. That's what it is given here. Some of the because the vehicle is not rotating about the center of mass, so that's 0. That's how you have to solve it. Similarly, this third problem which I am talking about is the motorcycle shown in a figure has a mass of 125 kg and a center of mass at G1. There are two center of mass. One is the vehicle center of mass, and the G2 is the the rider, the driver center of mass. So you have two different center of mass, and these positions vectors are given A and B. And now also you have to apply normal reaction and the weight, sum of the weight and both the center of mass. So that is towards the in the negative direction. So if you see that the wheelie, the term wheelie, that's why you have to read very carefully. The wheelie, the term wheelie is he is rising is the front wheel. So the friction at the front wheel is a 0. Neglect the mass of the wheels and assume that the front wheel is free to roll. So there is no friction. That's what it is. Emphasize that. So let us draw the free body diagram and apply the forces and resolve the forces. So we have to find out the NB and NA is a free wheel. If you assume that it's a free wheel, it's above the ground, then there is no normal reaction. So the NA is 0. So NB, FB, AG, we have to find out. There are three unknowns. So similarly resolve that in the MA, AG, in the x direction, MA, AG, in the y direction. now you have to do, because A doesn't have contact with us, so you have to take a moment at B, because you are raising the bike up, so the moment comes at B. So you resolve that, apply that 75 kg into AG plus 25 kg into AG is the FP. NB is equal to minus 73.5 minus this much is equal to 0. If you take this equation, F5 is the equations. So from that you can easily solve that AG is equal to 8 point. This mass, the acceleration at the center of the mass as center of location is 8.95 meter per second. NB is equal to 1962 Newton, and FP is equal to 1090 Newton. So dear friends, solving the problem is you have to systematically approach and solve that each and every time, which is not known, and there are known parameters given. Do it carefully, and nothing to be worried about, but you have to systematically approach that. And so my best wishes, and do well in the examination. Follow the simple professional procedure. As an engineer, you have to systematically solve this problem, and it has to be neat presentation, and there should not be any scribbling, and draw the free body diagram, and fix your coordinates, and direction, sense of direction, right and roll you can take it as, and then resolve the forces, take a moment if there is any unknown parameters are there, and you can easily solve that. Thank you. I wish you all the best.